Students, in this video we will discuss cubic interpolation method. So here in the previous video we have discussed quadratic interpolation, in which the problem minimum of f of x has been approximated by a polynomial of degree 2. However, in cubic interpolation method, the problem of this form minimum of f of x, where x varies from a to b, has been approximated by a polynomial px is equals to a naught plus a1x plus a2x square plus a3x cube, which is nothing but a polynomial of degree 3. Fine. So this is, in this problem, basically f of x is approximated by a polynomial of degree 3. Now here a0, a1, a2, a3, these are unknowns. So here, to find out these unknowns, we need 4 conditions. So 4 conditions are required, which may be: number 1, which may be f of xi is equal to p of xi. That means if we are following this, then we need 4 different points in the interval a to b, where I is 1, 2, 3, 4. That means 4 different points are used if we select this. In the second condition, f of xi is equal to p at xi and f dash xi, this is also known. That means here we need only 2 conditions, 2 points, where I is 1 to 2. And so if you put I is equal to 1 and 2 here, so we will have 2 conditions from here. And when you put I is equal to 1 and 2 in this derivative one, then again we will have 2 conditions. So 2 plus 2, that means 4 conditions. So here we need only 2 points. However, here we need 4 points. Okay. And the third one is some other cases maybe. So here among these 3, we will follow the second one. That means 2 points are given and derivatives are also given at these 2 points. Fine. So here let us consider case number 2. That means we will follow the second case. So px is given as a0 plus a1 x minus ax 1 plus a2 x minus x1 whole square plus a3 x minus x1 cube. So here we will not taking this form, rather than we are following this form to simplify the calculation. Fine. So here when you put x equal to x1, then p of x1 is nothing but f of x1, p of x2 is equals to f of x2, f p dash x1 is equals to f dash x1, and p dash x2 is equal to f of f dash x2. So these are 4 conditions. 2 conditions are simple conditions and 2 are the derivative conditions. Fine. Now here, to find out the derivative, first differentiate this px. So p dash x is equals to a1 plus 2a2 x minus x1 plus 3a3 x minus x1 square. So these are the interpolating conditions. Now using these interpolating conditions, put in this condition, put x equal to x1. So we will have first condition. So according to this condition, when you put x equal to x1 here, so what we will get? We will get a1 only, a0 only. This will be 0, this will be 0, this will be 0. So ultimately we will have a0, which is nothing but p at x0. P at x1 is a0, which is nothing but, according to this condition, as f of x1. So this is the first condition. Similarly, second condition implies, put x equal to x2 here. So what we will get? We will get this condition: f of x2 is equal to a0 plus a1 x2 minus x1 plus a2 x2 minus x1 whole square plus a3 x2 minus x1 cube. Okay. Now we will, when you use the third condition, the derivative condition, so we will use this derivative of px. Put x equal to x2 here. So this will be, sorry, put x equal to x1 here. So this will be 0, this will be 0. So we will have only a1. a1 is equal to p dash at x1 but this is equals to f of f dash x1. So we will have this condition. And the last condition is the derivative condition at the x2. So just take this, put x equal to x2 here, which we will get p dash x2 is equals to a1 plus 2a2 x2 minus x1 plus 3a3 x2 minus x1 whole square, which will be nothing but p dash x2, and according to this condition this will be f dash x2. Okay, so we will have this condition, last condition. So these four conditions we will have from these interpolating conditions. Now what is the necessary condition to get the optima? Because what is our target? Our target is to minimize f of x. So the necessary condition is that in place of f, because we will approximate f by p, so p dash at x star will be 0, where x star is the optimum solution. Okay, this is the question number 2. Then the sufficient condition will be that the second derivative at x star will be positive. This is the sufficient condition. Now from equation number 2, p dash x star will be 0. So, and here we have already taken the derivative one, so put x equal to x star here. So what we will get? We will get this a1 plus 2a2 x star minus x1 plus 3a3 x star minus x1 whole square is equals to 0. This is equation number 4. Now the equation number 3, this implies when you again differentiate this, because second derivative at x star is positive, so 2a2 plus 6a3 x star minus x1 will be positive. This is equation number 5. Okay, now we have equation number 4. So equation number 4 is this, which is a quadratic equation in x star minus x1. So when you find out x star from here, so what we will get? We will get this x star is equals to, so here we have two cases, when a3 is 0, when a3 is non-zero. When a3 is 0, then this term will be 0. So we have only linear term, and from here x star will be x1 minus a1 by 2a2. Okay, when a3 is non-zero quantity, then the solution is given by this x1 plus minus a2 plus minus a2 square minus 3a1 a3 divided by 3a3. Okay, so we have used the Sridharacharya. So this is when a3 is non-zero, and this term is when a3 is 0. Now in view of equation number 5, if you will see equation number 5, then we will have 2a2 plus 6a3 x star minus x1 will be positive. Then we will try to find out the sign of 6. Okay, so now 6 implies x star is equals to, that means we are taking this case. So x star is equals to x1 plus minus a2 plus minus a2 whole square minus 3a1 a3 divided by 3a3 when a3 is non-zero. So just take x1 in the left hand side. So we have taken x star minus x1 equal to minus a2 plus minus square root of a2 whole square minus 3 a1 a3 divided by 3a3. Now multiply this 3a3 in the left hand side and then take this a2 in the left hand side. So we get a2 plus 3a3 into x star minus x1. This is equals to plus minus square root of a2 square minus 3a1 a3. Okay, now multiply by 2. So we get 2a2 plus 6a3 x star minus x1 is equals to plus minus 2 square root of a2 whole square minus 3a1 a3. This is 7th. Now when you compare this 5th, so this quantity is greater than 0 and this quantity is also as it is same. So this left hand side should be greater than 0. So this should be greater than 0. That means this right hand side should be greater than 0. Okay. So here, since this quantity should be greater than 0, so that's why we can take positive sign rather than negative sign. So just take the positive sign. Okay. So take the positive sign. So when you are taking positive sign, so here we have plus minus. So in place of plus minus, just take positive sign. So x star will be x1 plus minus a2 plus a2 square minus 3a1 a3 divided by 3a3. Okay, when a3 is non-zero. So we have taken only positive sign. So x1 plus, now multiply and divide by its conjugate number, which is minus a2 minus square root of a2 square minus 3a1 a3. So just multiply and divide by the same quantity. So the numerator becomes x1 plus a2 whole square minus a2 whole square plus 3a1 a3 divided by, now multiply these two. So 3a3 minus a2 minus square root of a2 whole square minus 3a1 a3. So after simplification, 3 is cancel out with 3, a3 is cancel out with a3, so we get a1 only in the numerator one. So x star will be x1 minus a1 upon a2 plus a2 whole square minus 3a1 a3 if a3 is non-zero. Fine. Now next is when, so x star will be what? x1 minus a1 upon a2 plus square root of a2 whole square minus 3a1 a3 when a3 is non-zero, and x1 minus a1 upon 2a2 when a3 is 0. Okay, now the algorithm for this will be, so this is the algorithm. So minimum of f of x when x varies from a to b. Obviously f of x is a unimodal function. Okay, so step number 1, initialize with following interpolating conditions and get px. So we have only 2 points, and so at these 2 points we have this condition. At x1 equal to a, we have p at x1 equal to f of x1, and p dash x1 will be f dash x1. Similarly, at x2 equal to b, we have p at x2 is equal to f of x2, and p dash x2 is equal to f dash x2. Okay, this is a star. So by using these, we will get a0, a1, a2 and a3, and hence px will be a0 plus a1 x minus x1 plus a2 x minus x1 whole square plus a3 x minus x1 cube. Now step number 2, find x star. X star will be given by this. So x star will be x1 minus a1 upon a2 plus square root of a2 whole square minus 3a1 a3 when a3 is non-zero, and x1 will be x star will be x1 minus a1 upon 2a2 when a3 will be 0 using this. Okay, now stopping criteria will be if magnitude of f dash x star will be less than epsilon, then stop, and x star is the required solution. Otherwise go to step number 4. So to reduce the interval, basically we will apply the region elimination. So there are 2 cases. If f dash x1 is less than 0, and this is in bracket, this is in bracket, so either this condition holds or this condition holds. So either this and this, or either this and this. Fine. So in bracket we have when f dash x star is positive, or f at x star is greater than equal to f of x1. What is the meaning of this? Here the meaning of this quantity is what? That here the initially we have interval x1 to x2. Okay, initially we have interval because x1 is a, x2 is b. So this is basically a to b is nothing but x1 to x2. So here first condition says that this condition that derivative at x1 will be less than 0. That means decreasing. That means slope is decreasing in nature. Function is in decreasing in nature. Here at x star, because obviously x star is somewhere in the between x1 and x2. Suppose x star is here, then the derivative at x star is greater than 0. That means in increasing direction. Here, so either here increasing direction. So obviously if increasing, then here decreasing, here increasing. So obviously minima will be in between these two. And that's why you can eliminate this part from x star to x2. Okay. Now suppose this is not the case. Third condition is that you are not comparing the derivative, rather than you are comparing the values. F at x star is greater than f at x1. That means the value at x star is higher. So curve will be like this. Curve will be like this. Here I'm denoting this here. So here is, suppose this, so this is x1, and suppose this is x star, this is x2. So here the value is higher, this is the value. So if you, when you compare this value, this is negative decreasing, but x star is greater than this, so obviously minimum will be somewhere here. Okay, because this is decreasing and here the value is higher, so obviously this value is lesser than this value, so increasing, ये increasing होना चाहिए, and so obviously there should be a you can say peak in between x1 and x star, and hence again we are having the same case. Okay, so in this case eliminate this interval and the new interval will be x1 to x star. Fine. Otherwise, if this is not the case, then otherwise eliminate x1 to x star and take x1 star and x2 will be the next interval. Okay, so this is the second case. So either we have this case or this case. There are only two cases. Fine. So now we have taken example. So this is the example. Find the minimum of f of x is equal to x5 minus 5x cube minus 20x plus 5 by cubic interpolation method in the interval 0 to 3, and the tolerance is epsilon is equal to 0.005. Fine. So now iteration number 1. First find out the polynomial. Px is equal to a naught plus a1 x minus x1 plus a2 x minus x1 whole square plus a3 x minus x1 cube. Here x1 is 0, this point, and x2 is 3, right hand point. So P at x1 will be f of x1 according to the interpolating condition, and this is equals to 5. This is equals to 5 because when you substitute x1 is equal to 0 here, so you will get 0, 0, 0 and 5. So that's why 5. Now the second condition is the derivative condition. P dash x1 will be f dash x1 is equal to, first differentiate this and then put x equal to 0, so you will get minus 20 from here. So that's why minus 20. Now P at x2 is equal to f of x2 is equal to 53. Put here x equal to 3, x equal to 3 here, so we will get 53. And again when you are taking the derivative condition, so P dash x2 will be f dash x2 equal to 250. So these are the 4 interpolating conditions. Okay, so now based on these 4 interpolating condition, when you use these interpolating condition, so what we will get, a naught is 5, a1 is minus 20, 9a2 plus 27a3 will be 108, and 6a2 plus 27a3 is equal to 270. Okay, considering these 4 interpolating conditions. So after solving these last two conditions, we get a2 equal to minus 54 and a3 is equal to 22. So ultimately now we are having a naught, a1, a2 and a3. Okay, so polynomial is fully known, and now find out x star. X star is given by, since here a3, what is a3? a3 is this, and you will see that a3 is a non-zero quantity. a3 is a non-zero quantity, and hence x star will be x1 minus a1 upon a2 plus square root of a2 whole square minus 3a1 a3. So put it here, x1 is 0, a1 is known, a2 is known, a3 is known. So after solving this we get 1.8043. Okay, and now find out f at x star. F at x star is minus 41.3332, and the magnitude of this f dash x star will be 15.8411. This is the derivative. Okay, derivative is this, which is greater than epsilon 0.0045, sorry. So since here this condition, this the tolerance or the stopping criteria does not satisfy, that's why we have to move to the next iteration. So now we have to eliminate the region. So this is the actual curve. If you will draw this curve, then this will be the curve. Okay, so now f dash x1 is, f dash 0 is minus 20, which is negative. So because we have to apply this stopping criteria, this is stopping criteria. So we have first evaluate this derivative. So derivative at 0 will be minus 20, negative, that means decreasing. Now f dash x star is 1.8043, so minus 15.841, which is negative. So this is negative. So and f at x star is already evaluated, minus 41.332. So f at x1, f at 0 is 5. So we have evaluated all these values. So based on this first condition, if you will see here, this condition is satisfied, this condition is satisfied. However, this condition is not satisfied, f dash x star. this condition is f at dash x star is negative. Here this is positive, so this is not satisfied. That's why we will have the second case. Okay, again you can verify this condition also. F at x star is greater than equal to f of x1. If you compare this value and this value, so you will see that f at x1 is greater than f at x star. So this condition is satisfied. No, this condition is also not satisfied. This is all no, this is not satisfied. So hence we will have the second case. So hence if you will see, then we have to eliminate this interval. We will take x star to x2 as the next interval. So take eliminate x1 to x star, and x star x2 is the next interval. So next interval will be 1.8043 to 3, which is our new x1 x2 new. Okay, so x1 will be this 1.8043 and x2 will be 3. Again find out this polynomial with the help of these four interpolating conditions. So a naught will be minus 41.333, a1 will be minus 15.8441. Okay, p at x1, this is now new x1, x2 is the new x2. So again use the same conditions, but the values are now different. Here will be 5, however here is this, because f of 1.8043 is this is our x1 new x1. Okay, so again revise your conditions, and based on these find out a naught, which is this, a1, which is this. Put third condition and fourth condition, they will provide you the equations. After solving these two equations, what we will get, we will get the these two equations where, and from the, after solving these two, get a2 is equal to 15.3569 and a3 is equal to 53.4184. So again a3 is non-zero, so hence x star will be x1 minus a1 upon a2 plus square root of a2 square minus 3a1 a3. Simplify this, so we get x star equal to 2.0372. f at x star will be minus 42.9290, and the derivative at x star will be 3.8674. Fine. So now if you check the stopping criteria, the magnitude of f dash x star, then this will be 3.8674, which is again f greater than epsilon. So go to the next iteration. तो यानी कि हमें एलिमिनेशन करना है. So for which we need f at x1, f at 1.8043, which is minus 41.3332, f at x star, which is minus 42.9290. Derivative f dash x1 is equal to f dash 1.8043, so minus 15.8411, and f dash x star will be 3.8674, which is greater than 0. So you will see that this f dash x1 will be negative, that means decreasing in nature, and f dash x star is greater than 0, so this is positive. So here if you will look at the stopping criteria, then according to the stopping criteria, this condition is satisfied, this condition is satisfied, this condition is satisfied. So now you can eliminate the right hand part interval. Okay, so now here we will eliminate the x star x2 interval. Okay, so eliminate the region x star to x2. So the next interval will be x1 to x star. So that means 1.804232 to 2.037, which is your new x1 x2. Again revise your interpolating condition, p at x1 equal to f of x2, p dash x1 equal to f dash x1, p at x2 f of x2, and p dash x2 equal to f dash x2. So these are the revised condition, and based on this is your polynomial. So again solve this and find out a naught, a1, a2 and a3. So a naught will be minus 41.3332, a1 will be minus 15.8411, and a2 will be 3.31.2965, and a3 will be 31.5340. So since a3 is again non-zero, so x star will be x1 is minus a1 upon a2 plus square root of a2 whole square minus 3a1 a3. After simplification, value will be 1.9997. Now find out f at x star, which is minus 43, f dash x star, which is minus 0.0300. Take the magnitude of this quantity, so which is 0.0300, which is obviously greater than again epsilon. So go to the next iteration. Okay, so now For the next station, obviously we have to eliminate the region. So f at x1 will be f at 1.8043, which is minus 41.3332. F at x star, which is minus 43. F dash x1 will be f dash 1.8043, that means minus 15.8411, which is negative. And f dash x star will be minus 0.0300, which is less than 0. So you will see that f dash x star is again negative, that means decreasing in nature, and f dash x star is negative. So that means this condition is not satisfied. Now check this condition. So f at this x star is minus 43, and f at x1 is this minus 41.33. So obviously f of x1 is greater than f of x star. That means this condition is satisfied. Okay, so this is satisfied, this is satisfied. So eliminate the region x star to x2. Okay, so eliminate the region. So here, sorry, this condition is not satisfied, this condition is not satisfied, this is not satisfied, this is also not satisfied. Why? Because f of x star is minus 43, so this is less than this quantity. Okay, so now eliminate this region x1 to x star. Okay, so here eliminate this interval x1 to x star, and x star to x2 is the new interval. So when you take this new interval, so 1.9972 to 2.0372, this is your x star, this is your x2, and renamed as x1 x2. Okay, so x1 is there, x2 is there. Revise your conditions also. Find your a naught, a1. So a naught is minus 43, a1 is minus 0.03. Again with the help of last two conditions, a2 will be 50.68808, a3 will be 22.9390, a3 is again non-zero, and hence x star will be x1 minus a1 upon a2 plus square root of a2 whole square minus 3a1 a3. Substitute the values here. So x star will be 2. So x star is 2. So f at x star is minus 43. F dash x star is 0. Take the magnitude. So this is 0, which is obviously less than epsilon. So x star is 2. This is the solution. So stop. So stop. This implies stop. And obviously x star is equal to 2 is the optimum solution. Okay, so this is the solution procedure with the help of cubic interpolation method. Okay, thank you.